Consider problem 8.58 of Sonntag, in which we have water at 1000 kilopascal and 250 degrees Celsius, which is brought to saturated vapor in a piston cylinder in an adiabatic process. So it is an adiabatic process, and it is in a piston cylinder arrangement. Okay, so state 1, T1 equal to 250 degrees Celsius, P1 is equal to 1000 kilopascal. State 2 is brought to saturated vapor. Now, because it's an adiabatic process, let's assume it is a reversible process. If it is a reversible process, ds is equal to del q by t, which is equal to 0, because in an adiabatic process the heat transfer rate is equal to 0. So S2 is equal to S1. So this defines completely state 1, this defines completely state 2. We know both the states, so we must find out the final temperature. This is found out easily using these properties. So Q12 equal to 0 equal to U2. So we have been asked to find the specific work, we have not been given the volume of the cylinder, so we can work with specific quantities. Q12 equal to U2 minus U1 plus W12. This is equal to 0 because the process is adiabatic. So W12 is obtained using the state 2 and the state 1. Later on we have to compare it to the area using the PV diagram. So let's do this. So state 1, T1 is equal to 250, P1 is equal to 1000, state 2 x2 is equal to 1, S2 is equal to S1. S1 is equal to the entropy of steam at T equal to T1 and P equal to P1. So now we have all the states that we required. U1 is equal to int energy, steam at T equal to T1, P equal to P1. U2 equal to int energy, steam, x equal to x2 and s equal to s2. So W12 plus U2 minus U1 is equal to Q12. Q12 is equal to 0. Adiabatic process. This is because we have assumed reversible process. So for a reversible and adiabatic process, S2 is equal to S1. So let's see, the work done on the system is equal to 158.5 kilojoule. So let's try to plot this on the PV diagram. To plot this on the PV diagram, we must have the information about the specific volume. Recopy this. Similarly, okay, there we go. We plot property plot for water. It can be done for steam. We don't include any of the lines to the plot on the PV diagram. Okay, there we go. Plots overlay plot. On the x-axis we have the specific volume, and the y-axis we have the pressure. Okay, there is no, okay, we forgot to find out the pressure in the second state. So okay, plots, property plots, steam plots, overlay plot, the x-axis specific volume, on the y-axis the pressure. So this is the process. Okay, this is the process. So to find out the work done, we must simply find out the area under the curve. I'll leave that exercise to you as homework. Regardless, it should come out as 158.5 kilojoules.